Hey class, this is about graphing in standard form. This video specifically is. This frame in general is about our other two forms of quadratics. To remember, you always need to find the middle first. That is such a key important thing for graphing any quadratic. Otherwise, you are not going to get a nice parabolic shape. You'll only get a part of your parabola, and it's not going to look very nice. And it won't be correct because you won't have the middle. So standard form is what this video is all about. Standard form looks like y equals ax squared plus bx plus c. Now you've seen an a in the front before, and our a here actually still does the same thing that you're used to. We're going to find the first thing we're going to find for these is our axis of symmetry. And that formula is x equals the opposite of b over 2a. And those letters match up here. So here's your a that you'll plug in the bottom, the b you'll plug in the top. And one key thing you might want to remember on the bottom, probably want to put parentheses. A common mistake, students miss those when they put them into their calculator and then make mistakes. Our vertex is going to be still the x value that matches up with our axis of symmetry. And then to find the y value, you simply plug x into the equation. So it's a little bit more difficult, more work, much more work really than vertex form. That's why vertex form is really great. So let's graph one of these. Now on here on our frame, we should switch these around because really you're going to want to find your axis of symmetry first. It's easiest to find because you need that x value to find your vertex. So our axis of symmetry here is x equals the opposite of b. So here's my a, my b, and my c. So the opposite of b would be negative 2 over 2 times a is 2. So it's x equals negative 2 over 4, which is negative 1/2. So x equals negative 1/2. I'm going to try and graph this right in the middle here. Remember, our axis of symmetry is a dashed line, and we label it. We write it as an equation, always. You have to write it because it's a vertical line, so we write them as equations. To find my vertex now, I know I'm going to plug in a negative 1/2 here, and then I'm going to plug that negative 1/2 into my equation. So I'll do the work over on the side here. 2 times negative 1/2 squared plus 2 times negative 1/2 plus 4. So an easy way for you to do this, since you have a calculator, just plug that right into your calculator so you don't make any mistakes. If you plug that into your calculator, you will end up finding that you got 3.5. So it's negative 1/2, 3.5. You could also follow the order of operations and simplify, and you should get the exact same value. So negative 1/2, 3.5 is right up here. Now, A tells us the same thing as before. They didn't use the same letter to trick you. This A still tells us whether it opens up or down and how far will we go up or down when we move 1 from the middle. So my A value here is 2. So if I move 1 from the middle, I know I'm going to go down 2. But that's kind of tricky here because we're, again, in the halves. So for this one, I'm actually going to use a table. I think a table is going to make this a little bit nicer. So I'm going to use x, y. In the middle of my table goes my vertex, negative 1/2, 3.5. Now, for this table, we want equal spaces from the middle. So I go over 1/2, I'm at 0. Back 1/2, I'm at negative 1. So I'm going to have 0 and negative 1. Then I'm going to go 1 space from each of those points. That'll be 1 and negative 2. The best way, what's going to be the easiest for you since you get to use a graphing calculator, the easiest way for you to graph this is going to be to plug this into y equals in your graphing calculator and complete the table from your graphing calculator. If you don't plug it into y equals in your graphing calculator, the other option is to plug 0 in for each of these spots. Well, if you plug 0 into each of these will both go away, and we have 0, positive 4. And that's not a coincidence. Our c value is always, always, always going to be your y-intercept, because a y-intercept is when x equals 0. So if you plug 0 in for both of these, they'll always go away, and that'll be your y-intercept. So 0, 4 is our y-intercept, and because we went half away this way and half this way, it'll also be negative 1, 4. So I'll plot those. Different color here. Kind of hard because they're so close together. And then to find one other value, to plug in that 1 into your equation, plug it in for your x value, put it in your calculator, simplify, and you will find that it goes 1, 8 and negative 2, 8. And again, double check to make sure that they make sense, to make sure your points form a nice parabola, but these will. And again, to recap, we found our vertex first, because we always have to find the middle. So there's our axis of symmetry, x equals negative 1/2, plotted it. Our vertex is on there. My x value matches my axis of symmetry. To find my y value, I plugged my x value into the equation and simplified with the order of operations or the calculator. I then made a table with my vertex in the middle. I went equal spaces in both directions from the middle, and that way I repeat around the middle. And you can plug this equation into y equals in your graphing calculator and double check to make sure it makes sense. You can also double check here. A is 2, so if I go 1 from the middle, I should go up 2 to get back on my graph. And that would make sense right about there. All right, let's a couple examples. All right, we've got two actually pretty easy examples here. You'll notice these ask for the transformations. And the reason why we can do that, this one doesn't have a b or a c, and this one doesn't have a b. That b term in the middle, remember our standard form is y equals ax squared plus bx plus c. This b term moves our graph left or right. So because this first equation is missing a b and a c, c moves it up and down. No specific amount for the b, no specific terms left and right. C is always our middle, so that's 0. So this has no movement left or right, or up or down. So I know my vertex is going to stay right at 0, 0. Right there. My axis of symmetry goes right through my vertex, so it's x equals 0. Label it and draw it in there. Describing my transformations, 1/4 is less than 1, so we should say we have a shrink of 1/4, and my graph should be wider than the parent function. Now 1/4, still the a value, so it still tells us if we go 1 from the middle, we go up 1/4. 1 from the middle in both directions, we go up 1/4. So let's see if I can get that accurate here. Maybe up a little bit high for these ones. But for standard form, it's really best to make a table. The middle of our table always goes our vertex. We know if we go 1 in both directions, we're going to go up 1/4, so it's 1 1/4 and negative 1 1/4. 1 more in each direction would give me negative 2 and positive 2. Your first option is to plug this into your graphing calculator into y equals. Check out the table and see what goes here. Your other option is to simply plug 2 or negative 2, either one, into x, and simplify it. Remember, if you plug negative 2 and you have to have parentheses. So if I plug negative 2, it would be 1/4 times negative 2 squared. So that's 1/4 times 4. Negative 2 squared is 4, which is 1. So we have negative 2, 1, and positive 2, 1. Now looking, those make sense. It makes a nice wider parabola because we have a shrink of 1/4. So it's wider than the parent function. All right, let's graph the next one. Again, 5 tells us it's the a value of 5, so a stretch of 5. 1 from the middle, we're going to go up 5. And that 2 is going to be our y-intercept. Because there's no b term, our vertex just moved up 2. So our vertex is going to be 0, 2. 0, 2 is right here. So my axis of symmetry is x equals 0 still. Draw that dashed line Oh, both my ordered pairs I forgot to draw or to write in my ordered pair for my vertex. So it's x equals 0. My graph's going to open up, so I'll label my vertex below it. I'll go back over to the other graph and label my vertex while I'm thinking about it. All right, let's find some more points here. So if I go 1 from the middle, I'm going to go up 5. That's going to be way up here off my graph, but I need to have at least 3 points in my graph, so I'm going to draw those in, but I'm not going to find any more points than that because I know they would be way off my graph. There's my parabola. Describe the transformation. We know we have a stretch of 5, which makes sense for this graph. It's narrower than the parent function. And then we go up 2, which again, the vertex is moved up 2, so it makes sense. Always a good idea. Plug this into y equals. Double check it. Make sure your graph matches. All right, 2 more example problems. These are a little bit trickier because if you notice, they both have a b term. So that b term in both of these is going to cause my graph some left and right movement, but it's not the value of the b term. It does a little bit more changing than that. So these are really important to make tables with. Tables are going to be your friends for this. So let's start with our vertex. Actually, let's start with our axis of symmetry. X equals, we're going to do the opposite of b, so -4 over 2a. And a in this case is -1. Now remember, we want parentheses around the bottom if you just plug it into your calculator. So that's -4 over -2, which is +2. So x equals +2 is my axis of symmetry. I'll draw that in here. My vertex is going to have that same x value. Now we got to find our y value by plugging our x value into the equation here. So I'm going to do negative, or the opposite, because that opposite's already in there. So it's not inside parentheses. 2 squared plus 4 times 2. Now again, options. Follow your order of operations there, or plug it into your calculator and simplify. Either way, you should get 1 as your y value for your vertex. So I'm going to plot that. -2, or +2, 1 is right here. I don't know if it'll let me draw it in there. There we go. I'm going to look at my y-intercept next, so I get a nice easy point on here. Remember, your y-intercept is always the c value here. So I'm going to write that as my hint. Oh, it's always c. So my y-intercept is 0, -3. So 0, -3 is down here. Now just by those 2 points, I can see my graph is going to open down, which is what I would expect because this a value is negative. So I'm going to start my table here. Let's do it down at the bottom here, so where I have space. X, Y. In the middle is my vertex, 2, 1. Now 1 bigger from the vertex is 3. Another bigger is 4. 1 smaller is 1, and then another smaller is 0. Now I know a 0 goes 3. And because these are equally spaced, they're both 2 from the middle, I'm also going to have 4, 3. So, or 4, actually these are negatives. So -3 and 0, -3. That graph, that point is right here. Now I need my values 4, 1, and 3 now. And I notice that they're both 1 from the middle. And my a value tells me how far I move if I go 1 from the middle. So an a of -1, I go over 1 and down 1. So it'll be 1, 0. Over 1 and down 1. 3, 0. So there are my other 2 points. Formed a nice parabola, so I'm sure I'm correct. Double check what you have by plugging this into your graphing calculator. Compare the tables to make sure they match up, and make sure the graph looks right also. So the last thing here, state the maximum or minimum. your maximum or minimum is always at your vertex. So that vertex is 2, 1. I should have labeled that. And it's 2, 1. And because it's at the highest point of the parabola, it's a maximum. So my hint, it's always the vertex. All right, one more example problem here. So our last one. So I want to graph this equation. I notice it's got a b, so it's moved left and right. It's a little trickier. I'm going to need to do the opposite of b over 2a for the axis of symmetry. But that 3 right there, that's going to be my y-intercept, and a is positive 1, so it's going to open up. So let's start with the axis of symmetry. X equals, here's a is 1, b is negative 3, and c is positive 3. So the opposite of b is positive 3 over 2 times a, which is 1. So x equals 3 halves, or you might be more comfortable as a decimal, x equals 1.5. So 1.5 is going to be right here, right down the middle. I'll label it. There's my vertex, so my axis of symmetry. So 1.5 comma, to find this, again we plug 1.5 into the equation. You can put that in your graphing calculator or follow the order of operations. Either way, you should get 75 hundredths, so 0.75. So I'm going to graph that in a different color. So 1.5, 75 hundredths is right around here. Now, my a value is positive 1. So I know if I go 1 from the middle, I'm going to go 1 up. And then again, that's kind of in the middle. And I'd rather have exact x values from here. So I'm going to use my table. And my y-intercept as well. I still got that y-intercept of 3. So I'll plot that y-intercept of 3 because that'll give me a nice point. And look at, that's 1.5 spaces from the middle. 1.5 the other way is going to be right there. So I've got 2 points. My y-intercept was 0, 3. I can do this now. That's a minimum because it's the bottom point. And that's 1.5, 0.75. So in my table, I know my middle value is 1.5, 0.75. Now if I go 1 bigger, I'm going to have 2 and then 3. 1 smaller is 1 and 0. We know the 3 goes with it. And the 3 goes over here as well. We just need to find these 2 values. So you have the option of either plugging in a 1 or a 2 into the equation here and simplifying, or again, putting this into your graphing calculator and looking at the table. Either way, you will find that those values there are 1. So if I go over 2, I go up 1, and that makes sense because it makes a nice parabola in both of those spots. I'm going to draw it in as best as I can. All right, and so there's graphing in standard form. Key to remember, tables are very, very helpful in standard form. Our a value still tells us the same thing, 1 from the middle, but it's just a little bit more work to find the axis of symmetry when we've got that b in there. So have a great day.